Hello, everyone. Thanks for joining. It looks like people are still joining, so let's give everyone a couple minutes, and then we'll get started. It's 12:01. Again, appreciate everyone joining the call. Good afternoon to our attendees. My name is Vishal. I'm the VP of Marketing at MacroFab. Some of you might have heard me before. This is the fourth webinar in our series of digital manufacturing webinar that we started a couple months ago. It's a bi-weekly webinar series that we have been running. Great attendance, great questions that we get from our attendees. So continue the momentum. Anytime you have a question, people who have attended webinars in the past, they would know there is a section called questions. You can type in your question and I will ask the presenters the question at the right time. So we started this webinar series trying to cover the digital manufacturing space. Where is it today? Where are we headed? What are the issues people are facing in today's world? And what are the solutions out there? So the first one focused on an overall view of where digital manufacturing is and where it's headed, and really giving meaning to the term Industry 4.0. You know, it used to be a concept, not anymore. It's a practical word now. And then the second and the third webinar that we had was focused around, you know, from presenters from Altium and Geometry, especially Altium. You know, they showed us data around how supply chain issues are a big thing right now in our industry and it has been, you know, for past 12 months or so, and you know, they will continue to be that way in 2022 for sure, maybe in some part of 2023 as well. And that's where a lot of our attendees started asking us questions. You know, yeah, the problems are there, we understand it. What is the solution? What are you guys going to do for us? So that's why in this webinar we're going to focus on MacroFab as a tool. What is it that we do? How can we help you in the current scenario? Be the supply chain issue, how can you move your prototyping faster? And you know, so today's webinar is focused more around a demo of the MacroFab platform. Again, if you have any questions throughout the demo, please feel free to ask us questions, and I will hand this over to our presenter today, Chris Church.
Thanks, Vishal. So a little bit of background on myself. I am the co-founder and chief product officer here at MacroFab. I've spent a long time in software development, also in robotics and manufacturing. I've started both a robotics company and you know, moved into manufacturing. And particularly, one of the reasons I really moved into manufacturing was during my time running the robotics company. You know, we had a lot of challenges working with contract manufacturing. We had, you know, a lot of challenges getting pricing and real-time information out of our, you know, out of our manufacturers. So I really focused on, you know, I wanted to create a better experience around manufacturing, especially for the engineering and prototype stage, and especially around the handoff to production. So at MacroFab, you know, I work with the product teams, the manufacturing engineering, and the support teams to really focus on delivering a great customer experience. And our agenda today, we're gonna talk a little bit about MacroFab for those that are unfamiliar with us, and then we're gonna dive right into a platform demonstration. We're gonna cover three key areas: the engineer interface around pricing and placing prototype orders, and some of the capabilities we have there to really help you guys, you know, accelerate that process and get better feedback in your designs earlier. And then from there, we're gonna move to the transition from engineering to production. We're going to cover some topics like versioning, change tracking, and really handing off production designs to a purchasing team. And then finally, we're going to touch a little bit on the team workflows and how different individuals within an organization can work together to manage not just the prototyping, but the production for designs. Now, for those that are unfamiliar with MacroFab, we are a digital electronics manufacturing platform. We focus on PCB assembly, and our volumes go from 1 to thousands of units. We provide instant digital quotes for prototype and low volume orders, and we support, as I mentioned previously, the entire team in the process. So that means we work with engineers, purchasing teams, engineering managers. We kind of have a little bit of capabilities for all of the different roles there. And our focus is enabling companies of any size to really take advantage of digital manufacturing and lower their supply chain risk and agility. Now, some of the ways we do that is we don't have just one factory. We have over 75 factories in North America. We allow truly elastic production. That means you can have both very low volume, just-in-time orders, moving very quickly into higher volume production, and then shifting back because we enable the right jobs to go into the right factories at the right time. We can even, for several of our customers on larger volumes, we can actually produce that product in parallel in multiple regions, further reducing the risk. But with that being said, let's go ahead and jump into the demo itself. So when I first log into the MacroFab platform as an engineer, I'll come to a list of my printed circuit boards that I have managed with MacroFab. If I'm an engineering manager, I can actually access all the designs my different engineers are working on here, and we'll see that there under all organizations in the list PCBs for. But the first step is really creating a new PCB. So when I come in, if I click that button, I'll create a new PCB project. And for different types of tools, we have different files we can take in. For some, it's as simple as a single file. For some, we need a couple. And in each case, we provide instructions. Now, one of the things we are working for, going forward here in the future, is more direct integration into the EDA tools so that you wouldn't even have to go through this step. But that's something we'll cover at a later demo. So rather than kind of getting started here with a brand new project, I'm going to start out with one that's already designed so we can walk you through the different features and capabilities we have. So in this case, this product was designed in Eagle or Fusion 360, whichever way you want to look at that. And in that case, I literally just dragged and dropped my board file in to get started. We were able to extract all of the placement data, the design, the specifications for the board, and the BOM as well. Additionally, I can also, under the bill of materials, I can literally just drag and drop an Excel file here and bring that in if I'm managing my bill of materials separately outside of my EDA tool. But looking at the PCB, it is a fully interactive interface, so we can zoom into the design, we can look at individual layers, and we've got a lot of capabilities there. But one of our focuses is to really give you a what you see is what you get experience. So what we're showing you here is exactly how we, in all of the steps along the process, will interpret that design information. And this is an opportunity to look for any potential issues or errors. If there were a problem in that design, we can go ahead and call it out there very quickly. Opening the PCB specifications, now we have a lot more control. We try to extract as much as possible, but in a lot of cases with a lot of EDA tools, they don't always provide us all of the information we need. Now, obviously, we can do some basic things like controlling our solder mask color and our silkscreen, but we can also take full control over the stack up. We can come in here, we can specify the individual layers, the material in that stack up, etc. If we have multiple layers, so more than 2 layers, 4, 6, 8, we can then also control how our vias are created. So we could, if I had a multi-layer board here, I could control whether or not it's a blind or buried via set. I can control the back drills, micro drills, and whether they're filled or plugged. Now, one thing to note, we do handle up to 32 layers. We can handle more, but that would require a custom quote. Now, going back to the design itself, we've covered all of our specifications there, and we've come in. Now, here's where things really start to connect with the supply chain. So when we talk about the bill of materials, we're showing all of the components that are used in this design, but we're also getting real-time feedback from the supply chain. How much is currently available of each particular component and what the lead time is. Up at the top here, we'll also note, speaking of lead times, I have 4 options I can select here. For any given quantity, I can choose a different level of service, a different turn time, and of course, a different price associated with that. Now, we use all of the that input to determine the right vendors to purchase from to better control that price. Now, all of these things do update in real time. So if I were to change this quantity, not only will the pricing and lead time options change, but below the bill of materials will show me the new pricing and availability, and additionally how much we're going to consume. I'm going to go ahead and turn this back to 1 for now, for the purposes of this demonstration. Now, moving into the bill of materials itself, as we mentioned, we see the stock available, we see the lead time, total cost, and a quantity. Now, one of the things we'll see here in the quantity is not just the number of units needed to produce the quantity you have here, but also any potential wastage and overage. The first thing I'm going to do is I'm going to click on this first component, and we'll see that I don't have any stock available of the selected component. So here, my choice is to use this particular resistor, but obviously I don't have it available. So let me go ahead and search for some other options. And here we can go ahead and add more options to our alternative parts list. So looking below, we see there's several other components available with pretty high quantity. And I'm going to look at this and I'm going to say, I believe these will all work for me. In this particular case, it's a bit of a jelly bean component. So I'm going to go ahead and add a few of these to my component list. And it takes a moment for those to update. And now what will happen is I now have a longer list of components available to me. Let's go ahead and add that one as well. And so we can see now, these are all the components that I will allow in this position. And the system, since we're moving by price, has chosen to build my current quantity using this part. So once we come in there and once we identify our potential alternatives, we can search for those, we can add them to the list, and then as we're building, the system will automatically pick the right alternative based on your preference, whether you're going for that with the best price or that you want to go through a specific fixed sequence of components. And we can see here that the price updates in real time. Let me go ahead and switch back to the price model here. The price will update in real time, and we see not only the unit part cost, but we see the labor contribution. Now, one of the reasons why we show this is we feel it's very critical to understand how your design decisions impact your overall pricing for the product. And seeing just a combined labor price doesn't really tell you a whole lot about your decisions, because which of these components in here are really driving the labor cost. So we show you that at a component level, and we also show you the addition of the overage, how much that will impact the total cost by including this part in your design. Now, I did just touch on the alternates list, and one thing, while it's pretty straightforward to go through any one particular design and simply add a list of alternates for that design, a lot of times we tend to use alternates across a family of products. In some organizations, they will use internal part numbers, or we would call them custom part numbers. They would use a custom part number and then reference that across many designs, mapping that custom part number to a list of components which are allowed as alternatives for it. With the MacroFab platform, you can do that as well. You can define a custom part number, and now any design that uses that custom part number will automatically pull in that alternative list. The other thing we can do, if the particular part in this design isn't readily searchable, say it's a custom component or something like that, we can also manually add a part. We can provide an NPN and a manufacturer. Now you won't be able to place a self-service order using that part because we can't price it. We weren't able to find it on the market, but it can be captured in your design. And if you're moving into production, our sales team can work with you in providing that pricing. The other thing that we can do here, because we also understand that, you know, sometimes, even though parts are unavailable on the market, you may have previously purchased some, and you may, have an inventory of materials which you want to use across multiple designs. So we've also provided the option in here to specify whether this will be turnkey, that is, MacroFab is purchasing it, or it will come from consignment or inventory. And I'll touch a little bit more on inventory in a minute because we have some pretty advanced capabilities there. But the whole point of this is to give you control over how your board will be built and how the materials are sourced. So you're not kind of stuck with just doing turnkey or consignment. You can mix and match that as you like. Now, one of the things is this is a pretty simple bill of materials. But if I had a longer one, we see there's only about 35 rows in it. If I had a longer one, it could be very challenging to find issues that are occurring in that bill of materials, such as which parts are out of stock, which SMT parts are out of stock, etc. So these pie charts at the top are actually filters that you can combine to quickly identify issues. So thinking about here, right, I said I want to see my SMD components. Now show me which of those are unavailable. And right now they're all not populated. But if I were to, say for example, turn this off, we'll see that I have a populated part that is unavailable, and I can make a decision about what to do with that. I can either do not populate it, or I could go search for a new part. And I can quickly clear those filters. And we'll go ahead and do that here real fast. And now we'll see that I have all my parts are now being selected. For my unavailable ones, they're all not populated, so that should be no further issue for me. We can take some bulk actions here as well. We can group and ungroup items. We can upload a new bill of materials. We can even remove items from our bill of materials, and that's all made available to you here. As an engineer, a couple of the things that we're often looking to do, as I mentioned on pricing earlier, is typically we're designing a product that we're going to sell, and we're looking for a particular lead time, particular pricing, and we're getting feedback from our product owners. By showing all of the costs at a per line item level, we can get feedback and input quickly before we've even done our prototyping, before we've submitted this design to our purchasing team. We can get feedback quickly about whether or not we can hit our price targets and whether or not we can hit our lead time targets. For example, if I have a requirement for a part in my design that has a 52-week lead time and there's no stock available, like let's take a look here. We are looking for this particular microchip part. We'll see that there's no stock. It is 1 year lead time. Let's look at other form factors. Take a look and see if there's anything else in any other footprints for this particular part. Here we can see that this thing is out of stock everywhere. It's not expected to come back into stock anytime soon. As an engineer, now I know that if I want to build this product anytime in the near future, I need to go select a different part, and I may need to change my design around this. But going through that prototype stage, getting a working product, and then realizing that the supply chain doesn't support your product's go-to-market strategy is a real challenge, and you have to come back and reopen a design you already finished. Here, we're giving you that information as early as possible during the design phase, so you can quickly make those determinations and not have to go back and redesign later. Because we've all, for the engineers on there, we've all, you want to be working on a new design, you want to be working on developing something, you don't want to be responding to alternate part requests from your supply chain team, especially in the cases where there are, excuse me, where there are no viable alternatives. So that's at the bill of materials. As we move into the part placement, we can see all of the components that are going to be built on this board, including those that are missing. So in this particular case, I can see there's a handful of parts I'm not populating. If I really wanted to build this particular product, that might be a challenge for me. But you know, it's real easy to look at our bill of materials and think we have everything covered, and then realize, oh, hey, I missed one part. It wasn't in my bill of materials. So we can see visually which parts are going to be assembled on the board, and we can even make notes on those parts. So one of the things that was always challenging for me as an engineer is every time I go to a factory with a design, I have to go through a learning process with them about special instructions I may have for particular components. A big one is, do not wash this component for things like microphones, et cetera. And we kind of have to go through that each time. With the MacroFab platform, we can go ahead and put those notes in here, and they're available to the manufacturing team always when we're building it, so we don't have to answer those questions again. And we do encourage, if there's anything special that needs to be understood about particular components in your design, that you put those in here. And then finally, we get to the quote and order phase. And here it will go ahead and generate a new real-time quote for us. And we can see there are no issues with my design. I'm ready to order. But we'll also see something very interesting here. This chart on the right shows us our price at different quantities, so we can see how our price is going to scale out at volume. It goes up to 10,000 units. So if my product owner was coming to me saying, hey, we need this particular PCB needs to come to market at $13 a board at 10,000 units. Now we're kind of seeing we're still off target, right? We're at 20, about $20.50 here, and we could go ahead and resolve those issues. Likewise, we can see everything that is contributing to our cost down to the component level. And so if we get an idea of what makes up all of that cost, why is the price what it is, we can look at that just like we could see it in the bill of materials and in the design phase. We can see that as an aggregated quote. If we wanted to have a sort of a self-service experience, if I'm just checking out, what I can do here, if I want a prototype ordered, is I can go ahead and click order now, and I'll have a very traditional e-commerce experience. In this case, I'm going to get one board. I'm going to have it delivered in 14 business days, and we're going to go to the checkout process. It takes just a moment for that because we're creating the manufacturing job, if you will, so that it doesn't change once it's in production. And then at the order page, it is very similar to a traditional e-commerce checkout experience, right? We've got an address. We're going to have, for some reason, I don't see my shipping option here. I'll have to take a look at why that didn't pop up for me here. And then I can put in my credit card information and go. We'll come back to the order itself. I'm just going to come back over here. We're going to go back to the PCBs because in the next step here, I want to talk about the versioning and change tracking. We're going to come back to that order screen later when we talk about how we work with our other teams. So with any design, we keep a real-time tracking of every change that happens to it. And we can access that here under the change history. So here we can look at any different points in time. We can see what changed between those 2 points in time and who changed those. Additionally, if I have multiple orders of this product, I can pick those 2 orders and compare the differences between the PCB in in those orders. How that's often used, one of the big challenges we have, especially when we're doing iterations in prototype design, we'll make one change and then a different part of the design will stop operating. And a lot of times it can be really confusing. We think we changed just this IC over here, but the change history can show us that we actually changed, for example, a capacitor value. That will give us real clarity as to what difference what was in that design between those different iterations, and help to really quickly isolate what the issue might be. Now, in prototyping, we want to have a very flexible, be able to make changes on the fly, however we like. As engineers, we don't want to have to go through a very rigorous approval process to go and make changes to the BOM or the Gerbers, etc., until we've really locked down that design. But once we've vetted that design and we figured everything out, what we don't want to do is run the risk of having changes creep into that design afterwards. So once a design is finalized, instead of handing off a manufacturing package to a purchasing team to go out and have that quote, with the MacroFab platform, the engineers can actually come in and lock down and approve a design for production. So here, I've actually already got a version of this approved for production, but I've made a change. I can see the change here. I unpopulated, the OP1 part. So I'm going to call this revision 1.1, and then I will say here, revision 1.1. Now that I've done that, I can update that approval. And now I have a new variant of this product that is going to be available for my purchasing team, which they can access here. So for the purchasing team, they have their own area of the product. It's here under purchasing. And that enables them to come in here and see the different designs that have been approved for production. They can also manage RFQs. So a purchasing team can come in here and submit a new RFQ for something that's not in the platform. They can access their quotes. Oops, and let me get rid of that help screen there. And they can also see the status of all orders in the organization. When we're thinking about a purchasing team, you may have multiple engineers, you may have multiple production runs, and trying to get visibility into where every particular order is can be challenging. Traditionally, you kind of have to, go to your contract manufacturer and ask for an update. On the MacroFab platform, we will see every order, we will see its current status, we will see its delivery date, and all of that will be readily available to us in real time. Likewise, if there are any purchasing requests, which I'm just about to hop into in a moment here, they can see those. One thing I did mention earlier was the concept of inventory. Whether we're dealing with purchasing teams or engineers, it's not uncommon that companies have multiple components that they may have a significant stock of. And trying to consign that on each individual order is kind of risky. You're shipping the products back and forth; they could get lost. So we have a capability called build from inventory. So what we enable is, as an engineer, you can come in and define components that you want to use across multiple designs that you have some stock of. You can define them as an item in your inventory, and then you can ship those to us. You can actually create an inbound shipment and go ahead and just ship it to us. You don't need to talk to us. We will receive that inventory, and it will show up in your inventory screen, and then back on your bill of materials, you can then choose to consume that component from inventory. So it's one of the many ways we give you the flexibility, especially in today's supply chain challenges. We give you the flexibility to either let us source the parts for you. We give the flexibility for us to go out and custom quote those parts if it's not readily available on the market. We also give you the ability to consign materials you have or to store inventory with us. So really, we like to say it's not enough to have just sort of a self-service operation, but it's important to also give you the tools you need to be able to react to the current market conditions, whatever they may be. Now, moving into how the teams work together, we have the concept of what's called an organization. So when I click on my username, if I'm an administrator in my organization, I can come in here and see the different users that are available. I can invite my teammates in, and then I can specify their roles. So we'll see today, here I have 2 users and I have 2 roles, and I can come in and actually define what these users can do. So I can say, for example, whether or not they can only work on their own PCBs, and as an engineer, they can only order their own PCBs. I can also say whether, like for example, we have this role here called an engineering manager. They can kind of go edit anyone's PCBs and order those, or purchasers who cannot make changes, for example, to a design or any of the PCBs, but can order them and actually handle transactions. One of the things that we get asked a lot is, my engineers are not allowed to actually make orders, but I want an easy way for them to be able to submit these orders to purchasing without going through a lot of legwork and a lot of challenges. So what we've done, since I have a purchaser here, I can now go when I am about to check out, instead of putting it on my P card or whatever I have, I can actually go ahead and just send it to a purchasing manager and send it to them for approval. They will get an email that will say that this engineer is checking out this design. They'll have the full quote. They can come in, they can put in their purchase order number. If we have credit terms with the organization, those will be applied to the order, and they can advance that order and follow their normal purchasing approval process without having to create a lot of additional paperwork. So if they would, they could put it in the ERP or whatever system they track on their end, but now they're not having to send quotes back and forth in a bunch of emails. They can just literally click a button and bring that forward. The other things that we can do is, within the organization, we can manage what addresses people can ship product to, and you can really lock that down so that, if, for example, you really want to make sure that when your engineers are ordering prototypes, it's coming through a specific receiving process that matches that up to the purchase order in the system, and your inventory really tracks everything. You can limit the addresses the engineers can ship to ensure that it just goes to the right place. We talked earlier about the sharing alternative designs across multiple designs, or alternative component lists across multiple designs, and using customer part numbers. You can manage those here under the organization. So, very similar to how your PLM would manage those, you can come here and manage it centrally. And anytime someone uses one of those, you can keep those up to date without having to go edit each individual design. And likewise, there's a lot more we can do here. I just wanted to kind of briefly touch on this. But with the organizations, we really focus on enabling engineers to work with their organizations in whatever way your organization says that should be done. It's not enough to simply have a self-service checkout capability if your organization rules don't allow you to do that. Now, I think I have covered most things here. I think this is an opportunity, we can go into a lot of detail in some different areas, but if anyone has any questions or something that they would like to see more detail on, I think now's a great time to go ahead and open up the floor for that. Michelle, do we have any questions so far?
No, no one has typed any questions right now.
Okay.
And they are all muted. I can, the best way to ask questions, guys, would be to type in your question or raise your hand so I can unmute you.
Okay. And then, one of the questions I have gotten kind of often in the past is, how do I control the different parameters for my design? So we offer 4 different sets of DRC rules that we can apply against here. And each one will actually change the cost a little bit. It'll actually show you, as I do that, we can reduce, for example, we can go from a 5 mil minimum trace width to a 3 mil. And when I do that, let me go ahead and I'm going to set my time frame here. When I do that, we'll actually see under the PCB charges, we'll see the additional one-time charge for doing that. And that updates obviously as I increase my quantity. We'll see that all those costs actually work themselves out. So in this case, it's only $1.87 a board to change that particular setting. Okay, so we'll keep it open here for another minute for audience questions. And like I said, I'm here. I'm happy to answer any questions you might have about our capabilities or using the MacroFab platform. But just wanted to give a quick demonstration today and cover some of the common use cases we have.
There's a virtual hand raise, guys, on the webinar. You can raise your hands virtually. I will unmute you. You can ask a question that way, or you can type your question in the comment box. I think this was great, Chris. There is a question.
Okay, excellent.
Can you show a bit more about the custom part number versus MacroFab part number and how you use it in the design?
Okay, yeah, so looking at the custom part number, let's go ahead and load this up. I'm gonna rebuild this BOM. Now, when I open this part, we'll see that I have a list of alternate parts, but there is no custom part number. So I'm gonna go ahead and create, we're gonna create one here. We're gonna call it, we'll call it this, right? When I save that, I can now reference that same custom part number in any of my bill of materials, and it will automatically load this. So I'll give you a quick example of doing that. We called that CCD 100-101. So I'm going to search for 100-101, and it will search both my custom part numbers and the marketplace. And we'll see I have this here. I can now select that part, and it has reconstructed the alternate part list for this. If I now go to my, if I go to my organization, I can also see that in my custom part list here, and I can see all of the parts that are in it. So the idea there is, in some organizations, you manage your AVLs centrally, like through your PLM system, and then you reference a custom part number, your own internal part number in the design. We can do that, and how we will build those initially, if you don't want to do it manually, you can actually upload an Excel spreadsheet that defines that custom part number and the multiple manufacturers and NPNs you allow there, and we'll automatically build that list for you on the first time you import a BOM using it.
I think that's it, Chris. To all the listeners, feel free again. We'll be here for a minute or so. Ask your questions, raise your hand. And for reference, you guys can go to macrofab.com/webinars. That's where all of our webinars that we have conducted until now are available on demand. So you can go through all of our webinars and see the topics that we have covered. This is an ongoing webinar series, as I mentioned before. So today was a demo of MacroFab. We'll continue to bring in our co-hosts from Altium and Geometry as well. So the whole purpose of this webinar series is more knowledge sharing, right? So you have folks from Altium joining in, which also has components of Octopart, right? So you get multitudes of views of design as well as the component arena from Altium, and then you have MacroFab. We help you move from prototype to production, and then you have Geometry from a mechanical part prototyping perspective. So our goal with this webinar series is to educate our audiences, and this is an area where you can come in, ask questions, and learn something new. And that's why we schedule it around lunchtime, so it's more like a lunch and learn that we like to do. So as I said, go to macrofab.com/webinars, and all of our new webinars we will conduct on a bi-weekly basis will be available there, and others are available on demand. Chris, I don't see any more questions, no more hand raises. I think we're good to go
All
for
right,
today.
excellent. All right, well, thanks everybody. And if you want a more specific demonstration with one of your specific designs or you need some help, just reach out to us at support@macrofab.com and we can go ahead and schedule that. We can get somebody on the phone and walk you through that, or even do it, digitally online. So just let us know anytime you need any help or if you want more information, and we'll take care of it.
Thanks, guys. Appreciate it. See ya.